Hello, Algebra 1. This is your study guide, and I will talk over the things that you need to know for the test on Monday. The first thing is you absolutely positively need to know the parent functions, and you have to know how to graph them with their 5 points. So please do that right now and see how you did. All right, so take a look at those graphs and notice that I am plotting 5 specific points on each graph. The only graph that I did not use -2, -1, 0, 1, and 2 as my x values is the one that does not have the red points right here, which is our our square root function. And remember, we can only plug in perfect squares, so we plug in 0, 1, 4, and 9, and we get 0, 1, 2, and 3. So know those values. Okay, so going back on, let's see the rest of the study guide. So the first thing it says is sketch the parent function, sketch the given graph with horizontal and vertical shifts. So the first thing I'm going to do is, this is my parent function, it's the square root function 0, 0, 1, 1, 4, 2, and 9, 3. Now I'm also going to write those points down on the side over here just to show you another way that I could do the transformations. So 0, 1, 4, and 9, and I got 0, 1, 2, and 3. Okay, when I look at this, I notice that there is an horizontal shift that's going to take me to the left 4. So that means I would subtract 4 from all my x's, and there's a vertical shift that's going to take me down 5. So I would subtract 5 from all my y's. So what I'm going to do is I'm going to do that on my ordered pairs. I get -5, -4, -3, and -2. And then over here I'm going to subtract 4, so I get a -4, a -3, 0, and 5. So now I just have to plot those points. Or I could think about that I took each one of these points and I moved them left 4, 1, 2, 3, 4, and down 5, 1, 2, 3, 4, 5. So you could just check and see, is that one of your ordered pairs that we wrote? And it should be. It is the ordered pair -4, -5. So basically you would just move each one of those pairs. We have the point -3, -4. We have the point 0, -3, and we have the point 5, -2. So when I'm done, I get the square root function. Okay, the next guy here, this is our exponential function, and if you recall his original ordered pairs, we start with -2, -1, 0, 1, 2, and we get 1/4, 1/2, 0, 1, and 4. Sorry, 2 and 4. Okay, so when I look at what's happening here, inside of the parent function it says -4. I'm going to do the opposite because that's an IHOP, and I'm going to go to the right 4, and then we have on the outside a +2, so it's a vertical shift up 2. So that means to my ordered pairs I'm going to add 4 to my x's, and I'm going to add 2 to my y's. So this becomes 2 1/4, 2 1/2, 2, 4, and 6, and this becomes, if I add 4, 2, 3, 4, 5, and 6. And then I would just plot those points accordingly. So I have the point 2, 2 1/4, that's kind of hard to plot. I have the point 3, 2 1/2, which is a little bit higher. I have the point 4, 2, and 5, 4, and 6, 6. So go ahead and plot those and see what you get, because I don't want to waste time on that. All right, down here, graphing with horizontal, vertical stretches and shrinks. So let's just talk about what happens there. These are both on the outside of the parent function, so that means they're vertical, and it's the same as what we expect. That negative, remember, whenever you see a negative is a reflection. If it's on the outside, it means I'm changing my y's. So if I change my y's, it's going to reflection over the x-axis. So all I'm going to do is multiply all of my y's by a -1. And then the 5 out there is a vertical stretch, BAFO 5. So I'm going to multiply by y's by 5. So if I put my original ordered pairs, remember they're -2, -1, 0, 1, 2, and 4, 1 squared is 1, 0, 1, 4. So I could take care of both of those transformations by just multiplying by a -5. So I'd have a -20, a -5, 0, -5, and -20. This one clearly is not going to fit on our graph, so you're going to have to change the scale of your graph or make a new graph. Okay, this guy next door to it, notice that they're both on the inside, so these are both IHOPs. You can do the opposite of what it says. The negative says that it's a reflection over the y-axis because I'm going to multiply all my x's by a negative. And then remember, we do the opposite of what it says. It looks like we're going to shrink it because of the fraction, but remember, it's actually going to be a horizontal stretch, BAFO 3. So what that means to me in my original ordered pairs, this is the cubing function, -2, -1, 0, 1, 2, -8, -1, 0, 1, 8. And then what I'm going to do is I'm going to multiply all of my x's by a 1. And then I'm also going to multiply them by 3. So let's just multiply by negative 3. So that'd be 6, positive 3, 0, negative 3, and negative 6. And then you could plot those and take a look and see what you were supposed to get on your answer. So here we go. We'll show you what these graphs are supposed to look like. All right, moving right along. Let's look at the next part of the sheet that you need to understand how to do. Multiple transformations and domain and range. So first off, I'm going to go and I'm going to put my V's and H's. Vertical because it's on the outside, horizontal, vertical. There are 2 vertical transformations. Remember, you have to do the multiplying ones first. So this is a vertical shrink, baffle 1/4. And then we're going to take this graph and we're going to vertically shift it down 4. And then there's 1 horizontal transformation. Oops, sorry about that. And the horizontal transformation is a shift, and we're going to go to the left 2. So if I was doing my ordered pairs from the table, this is the absolute value function, so I could plug in negative 2 to positive 2. Remember, everything comes out positive. And to my y's, first I have to multiply by 1/4 or divide by 4. So that's 1/2, 1/4 stays 0, 1/4, 1/2. And then what I have to do is I have to subtract 4. So these are not going to be the prettiest numbers. 1/2 minus 4 is a negative 3.5. 1/4 minus 4 is a negative 3 3/4. This will be a negative 4. And then we have the same values, negative 3 3/4 and negative 3.5. The x's, all I have to do is subtract 2 from them. So it would be a negative 4, negative 3, negative 2, negative 1, and 0. And then you would plot those. So let's take a look at what that graph should look like. So when we're done, that graph should look like that. And here is your domain and range. So go ahead and check that. All right, back to the one before it. I see the square root function. Remember, the square root function needs to be perfect squares only, 0, 1, 4, 9, and we get 0, 1, 2, 3. I'm going to multiply my y's by a negative 2 first. That's a vertical stretch by a factor of 2 and a reflection over the x-axis. And then I'm going to add 2 to my y's because I'm going to shift them vertically up 2. So multiplied by a negative 2 gives me these values. And then if I add 2 to each of them, it gives me these values. And my x's, the only thing I need to do is reflect them over the y-axis, which means change their signs. So it would look like that. So if you plotted those points, you would get a graph that looks something like this. And the domain on that, notice, only goes up to 0. And the range on that only goes down to 2. All right, and our last part, describe what's happening here. So as x goes to infinity, look at the arrow, y is going to a negative infinity. As x goes to a negative infinity, your y is going to a positive infinity. Over on this one, as x goes to a negative infinity, y goes to a negative infinity. As x goes to infinity, y goes to infinity. Okay, are there any relative mins or maxes? So here's a relative min here, and here's a relative min here. So remember, the minimum is always the y value. So it's the relative min is a negative 3 when x is a negative 4, and this has a minimum of, it looks like a negative 4. I'm having a hard time telling. When x is 2. Okay, so you get the idea on that. This graph does not have any absolute mins or maxes because it continues going on forever pointing up and forever pointing down. And where is it increasing? These yellow intervals, and it's decreasing on the green intervals. Remember, when we talk about increasing and decreasing, we always use the x values. So when I say where is it increasing, this first section right here, I would say it's increasing from a negative infinity up to a negative 4. And then I'd also say it's increasing from, oh shoot, that was decreasing, guys. Sorry about that. We'll do the decreasing ones right now. It's decreasing from a negative 2 to 3, and then it's also decreasing on this section from 5 to infinity. So the increasing ones then are the yellow ones. And so it's increasing from a negative 4 to a negative 2. Remember, we switched these two around. And it's increasing from 3 to 5. All right, I'm going to leave the other one for you to do. Check it out, see how you do. And here's what you should have gotten. Oh, darn it, they're not there. All right, so let's write the answers right now. Okay, so we already did what happens to the end behavior. So let's just talk about the relative mins and maxes. This one has a relative minimum right here. So the minimum would be 1 when x is 0. There are no relative, there's a relative maximum right here. So the maximum is at 8 when x is a negative 4. And then there are no absolutes because there's arrows on both ends. There's 2 intervals where it's increasing. So it's increasing from a negative infinity through a negative 4. And then finally it's increasing from 0 to infinity. Okay, and where is it decreasing? Just in this blue section right here, which is from a negative 4 to 0. All right. Algebra 1, good luck. Please study everything that I showed you on your study guide, and I'll see you at your test on Monday. Have a nice weekend.